To achieve a range of 300 to 400 miles, a battery with the capacity calculated as range in miles divided by fuel cost per mile in dollars per mile times electricity cost in dollars per kilowatt hour equals battery capacity in kilowatt hours would be needed. Using 400 miles divided by 0.125 times 0.13 equals 3,200 kilowatt hours. Using lithium-ion batteries with a density of 0.25 kilowatt-hours per kilogram, the weight of the batteries would be battery capacity in kilowatt-hours divided by battery density in kilowatt-hours per kilogram equals battery weight in kilograms. Using 3,200 kilowatt-hours divided by 0.25 kilowatt-hours per kilogram equals 12,800 kilograms. This is significantly heavier than an entire Honda Civic, which weighs approximately 1,290 kilograms, making the car impractical. At 90 miles per hour, a Honda Civic consumes around 0.13 gallons of gas per mile, which equates to 1.1 kilowatts. Horsepower times 0.746 kilowatts per horsepower equals power in kilowatts. 140 horsepower times 0.746 kilowatts per horsepower equals 104.4 kilowatts. Therefore, the Civic's engine has an efficiency of power in kilowatts divided by fuel consumption in kilowatts equals efficiency in percentage. 104.4 kilowatts divided by 1.1 kilowatts equals 94.9%. Electric motors have efficiencies of around 90%, so they are comparable to gasoline engines. The annual fuel cost for a Civic with a mileage of 20 miles per gallon and an annual mileage of 15,000 miles would be annual mileage in miles divided by miles per gallon times fuel cost in dollars per gallon equals annual fuel cost in dollars. 15,000 miles divided by 20 miles per gallon times $2.50 per gallon equals $1875. To achieve a comparable cost per mile with electricity, the battery would need to last for annual fuel cost in dollars divided by fuel cost per mile in dollars per mile times electricity cost in dollars per kilowatt hour equals battery lifespan in years. $1875 divided by 0.125 times 0.13 equals 118 years. This is far beyond the typical lifespan of batteries, which is typically 5 to 10 years. Based on current technology, it is extremely challenging to make an electric car that meets the objectives, particularly due to the weight and lifespan of the batteries needed for a practical range. A major technological leap in battery technology is required to overcome these limitations and make electric cars a viable alternative to gasoline-powered vehicles.